Now we are going to learn about different combinations of resistors and cells and their different applications. By using Ohm's law, we can easily calculate the current through any resistor. Resistors are joined together to form many combinations. We follow some rules to calculate their equivalent resistance. Two resistors are said to be in series if only one endpoint is joined. We can now join one more resistor with the series combination of the two. Then all three are said to be in series. This definition can be extended to any number of resistors in series. Two or more resistors are said to be in parallel if one end of all the resistors are joined together and similarly the other ends joined together. Now let us consider two resistors R1 and R2 connected in series. The charge which leaves R1 must be entering R2 and rate of flow of charge is current. Hence, the same current flows through resistor R1 and R2. Potential differences across the three different resistors are as shown. The potential difference V across the combination is as shown. Now this is as if the combination had an equivalent resistance R equivalent, which by Ohm's law is R equivalent equals R1 plus R2. If we had three resistors connected in series, then similarly V will be I into R1 plus R2 plus R3. This obviously can be extended to a series combination of any number of resistors R1, R2 up to Rn. The equivalent resistance R equivalent will be simply the summation of all as shown. Now consider the parallel combination of two resistors. The charge that flows in from point A flows partially through R1 and partially through R2. Hence, different currents I1 and I2 flows through R1 and R2. Hence, I equals I1 plus I2. The potential difference between A and B is given by Ohm's law applied to R1 as shown. Also, Ohm's law applied to R2 gives the following result. Therefore, finally I equals I1 plus I2, which equals V into 1 by R1 plus 1 by R2. If the combination was replaced by an equivalent resistance R equivalent, then by Ohm's law, we would have the following. Similarly, three resistors can be connected. Just connect the two ends of the three resistors between two common points. Exactly as before, I equals summation of I1, I2 and I3, and applying Ohm's law to all three resistors, we get the following. An equivalent resistance R equivalent that replaces the combination would be such that I equals V by R equivalent, and hence we get the following. We can reason similarly for any number of resistors in parallel. The equivalent resistance of n resistor would be as shown. Note that these formulae for equivalent resistance can be used to find out currents and voltages in more complicated circuits. The combination of resistors can be mixed also. Here R2 and R3 are in parallel. The combination of resistors can be mixed also. Here R2 and R3 are in parallel and their resultant is in series with resistor R1. R2 and R3 are in parallel and hence we can replace them by an equivalent resistance between points B and C as shown. The circuit now has R1 and the equivalent resistance R23 in series, and hence their combination can be replaced by an equivalent resistance as shown. If the voltage between A and C is V, the current I is given as shown.